So for the last part of our work here with these sine and cosine functions is we're going to work backwards. Instead of graphing an equation, we're going to try to figure out what the equation is from the graph. The reality is with any of these wave functions, we can identify them as being either a sine or a cosine function. And that just depends on where we start. If we start at a 0, so for example like this location right here, then it's a sine function, because that's where the parent graph starts. Sine starts at 0. But if we pick this top point right here, for example, or one of the bottom points, then it would be a cosine graph, because cosine starts at a maximum. So let's focus in on writing it as a sine function first. So I'm going to fill out y equals a times sine b times x minus h plus k. And so now I have to figure out what number goes in the positions of a, b, h, and k in my equation. So first off, I can see that I have no vertical translation. The graph is centered on the x-axis. So the k is going to end up being 0. So it's just not going to be there. I'll put that in as plus 0 for right now, but really we'll be able to eliminate it in a minute. We can see what the amplitude is. So we can go back to the beginning of the equation. So I can see that the graph bounces off of 2 and negative 2. So I can put a 2 out in front there. And it's a positive 2 because from this spot right here, the graph is going up. So that's what we would expect from our standard sine curve. We can look for the period. So we just have to pick any two spots. It doesn't have to be from the spot that we're starting at to try to determine what the period is. How long along the x-axis does the graph take to complete a full cycle? And so the easiest spot for us to kind of determine that would be here between these two locations. And we can see from bottom to bottom, it's a distance of 2 pi. So that means our period is our standard period of 2 pi. And so that means b is going to be 1. So I can get to here, so I've got 1 times x, and now I just have to figure out what that phase shift is. What is that horizontal translation? Well, it's not labeled for us directly, but we can see that if the second tick mark is pi, then that means the first one here must be pi over 2, and so that's our phase shift, so minus pi over 2. And so we already have the plus 0 there for the k, so if we want we can go ahead and eliminate that, and so we don't even need that 1 in the b position. We've got our equation. Now we can also write it as a cosine function. So now again we'll use this top location here and rewrite this as a cosine graph. So the only difference here is that we're now going to have cosine in place of sine. So we can go y equals, now the amplitude is going to be the same. That's no different. It's still bouncing off of 2 and negative 2, so that remains the same. I'm going to have cosine. My period is unchanged as well. Just because I'm changing the starting point of my graph, the period is not changing, so the b value is still going to be 1. I'm still going to have 0 as the vertical translation, so the k is still going to be 0 over there. The only thing that's going to be different now is going to be the phase shift. I now am no longer starting my graph at pi over 2, I'm starting it at pi. So I'm going to have a minus pi. So we've got 2 times the cosine of x minus pi. So we'll close things out with one more of the same type of question where we're trying to write the equation of a graph that's been provided for us. And we've got to write both a sine and cosine function. So for the sine graph, we'll use that as our starting point. So we're going to use this same equation up here. We have to fill in our values for a, b, h, and k. Now for starters, we can see that there is a k value in this one. Right? Our graph has been translated up 2 units. If we kind of look there, we can see we're counting by 2's along the y-axis. So I'm going to have a plus 2 kind of hanging out in that k position. From there we can determine the amplitude. So from that horizontal dotted line, from that sinusoidal axis, we're traveling up 4 units and down 4 units. We're going up as high as 6, down as low as negative 2. So our amplitude is going to be 4. But because I chose the starting point that I did, the graph is not going up from that 0, it's going down. And so as a result, that means we've experienced a reflection in our graph. So that means my amplitude needs to be negative. I need to have a negative 4. So then we've got sine, have to determine what the value of b is going to be. So we've got to look there we've got to determine what the period is. And so if we again look kind of at an easy spot here to get from bottom to bottom in our function, we're traveling a distance of pi over 2. That does not mean that b is pi over 2. That means the period is pi over 2. And so recall that the period is 2 pi over b. So if the period is pi over 2, I can plug that in for the period. And now I have to figure out what does b have to be so that my fraction on the right-hand side will reduce to pi over 2. So hopefully we can see that b has to equal 4. If I replace b with 4, 2 pi over 4 will reduce to pi over 2. So our b value is 4 for our equation. We're going to plug that in, and then x, and then if we look what we're counting by on the x-axis, the second tick mark was pi over 4. That means every tick mark is pi over 8. But because I went to the left, it's a negative value, and since in our equation the h value is being subtracted, it's going to show up as plus pi over 8. And then we already have that plus 2 on the back end for the vertical translation, so we've got the equation for that graph as a sine wave. If we want to write it as a cosine wave, we can go ahead and use this location here. Again, any maximum or minimum will do, but if we go with that one, we've got y equals, our amplitude is still 4, that's unchanged, but this time it's going to be positive 4 because we're starting at the top. It's now a cosine function instead of sine. Our period is the same, that has not changed by switching from sine to cosine, so that means our b value is still 4. We are, however, going to have a different phase shift. The phase shift this time is not going to be that negative pi over 8, so showing up as plus pi over 8 in the equation. This time we've moved to the right pi over 4, so we're going to have minus pi over 4, but our vertical translation is still the same, so we'll have that plus 2.